Hello, let's begin session number 20. The topic is deadlock definition, deadlocks. So, in this session, we are going to see what is the deadlock. So, in this session, deadlock objects, bridge crossing example, resources, the deadlock problem, deadlock characterization, condition for resource deadlocks. So we are discuss one by one in this session. First of all, we are going to see what is the deadlock. Deadlock means what here? A deadlock is a situation where a set of processes are blocked because each process is holding a resources and waiting for another resources acquired by some other processes. This situation we are going to call what? Deadlock. So I repeat once again, a deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other process. So this is what we are going to call deadlock. For example, I give one example for here for deadlock. Two trains are coming towards each other on the same track and there is only one track. None of the train can move once they are in front of each other. So here what happened? The two trains are coming on the same track from both the side. So they cannot move side because of what? They are coming from the same track. So there may be happens what? Deadlock. So this is an example for what? The deadlock. So objective here to develop a description of deadlocks which prevent set of concurrent processes for completing their task. So here what happened? Develop a descriptions of deadlocks which prevent set of concurrent process for completing their tasks. So these are objectives to present a number of different method for preventing or avoiding deadlock in a computer system. So these are the objectives. So here one more example for the deadlock, how the bridge is crossing car. Here some vehicles are passing throughout the bridge, but while in the middle there is a very small bridge is there. So there only one vehicle can pass at a time, but here in this diagram there are two vehicles are coming in front of each other. So here what happened? The deadlock will going to be happen. So traffic is only one direction, means in the sense of what here? The traffic is only one direction, but both are coming from in front of each other. Each section of the bridge can be viewed as a resources. So these are the resources. If deadlock occurs, it can be resolved if one car backs up. Means if here what happened? There is a deadlock has been happened, but we can solve this. How? One vehicle or one car need to back up, means he come to back and give chance to pass to other car, then only we can solve the deadlock. preempt, resource or rollback. Several cars may have to be blocked up if a deadlock occurs. Means here what happened? Those vehicles are also coming. They are again come and wait for a vehicle back. So again it should be occurs the deadlocks here. So starvation is possible. So here what? Starvation has been possible. Note, so this is the example for what? The bridge for crossing the vehicle. So this is deadlock. So what are the resources? Resources are types of R1, R2 up to RM, the CPU cycles, memory space, IO devices. Each resource type RI has WI instance. So these are the resources and WI are the instances. Sequence of event required to use resources: request the resources, use the resources, release the resources. So using these three are the resources. The process in operating system use the different resources, uses resource in the following these three: request the resources, use the resources, release the resources. So what is the deadlock problem? A set of blocked, here what happened? Set of blocked processes, each holding a resource, and waiting to acquire a resource held by another process in the set. So here what happened? One process is already acquiring and executing, and one more process is wants to execute and it is holding other resources. So this is what? Deadlock problem. So for your example, system has two disk drive, P1 and P2, each hold one disk drive and each need another one. So here below one more example, the semaphore are A and B initialized to 1, P0, P1, wait A, wait B, wait P, wait A. So this is what? Deadlocks in the semaphores. So resource acquisition here. So how we can write the code for one resource and two resource to protect the resource through semaphores, using semaphore. So type definition here: in semaphore rates resources 1, wide process avoid, down resource 1 use the resources, up the resources. So these are the code for resource 1 and similar resource 2. So here one more resource acquisition given 2. For A diagram is A code is shows that deadlock free, and B is shows that deadlock with potential deadlock. Deadlock definition: a set of processes deadlocked if each process in the set wait for an event. That event can be caused only by other processes. So what are the characterization here? Deadlock characterization: mutual exclusion. Mutual exclusion means what here? The only one process can run at a time. So here only one process at a time can use resources. Second characterization: hold and wait. A process hold at least one resource is waiting to acquire additional resources held by other processes. So third one here, no preemption. A resource can be released only voluntarily by the process holding it after that the process has completed its task. Wait, next fourth one, the last one, that is circular wait. There exists a set P0, P1 up to Pn of waiting processes such that P naught is waiting for a resource that is held by P1, P2, P1 to Pn is waiting for a resource that is held by P2 up to Pn minus 1 is waiting for the resource that is held by Pn, and P0 is waiting for the resource that is held by P0. So these are the circular wait. Here condition for deadlock resources, these four are the condition must be hold, mutual exclusion, hold and wait, no preemption, circular wait, condition. So these four are the. So what are the method of handling deadlock? There are totally three methods are there to handling this deadlock. First one, deadlock prevention or avoidance. The idea is not to let the system into a deadlock system. Once can zoom each category individually. Prevention is done by one of the above mentioned necessary condition for the deadlock. So second one is deadlock detection and recovery, and third one is ignore the problem altogether. So these three are the what for the deadlock handling for the deadlocks. So deadlock modeling is here in the diagrams are given. So R resource 1 holding a resource. In the B diagram, the requesting a resource. So here requesting resource is B, and C is what here happening deadlocks. So basic fact, if the graph is contain no circles, means no deadlock. If the graph is contains no cycle, then there is a no deadlock. If graph contain a cycle, if only one instance per resource type, then deadlock. If several instances per resource type, possibilities of deadlocks. So here one more deadlock modeling is given. The number of requests and number of resources are given here. How this request and releasing. So here R1 is handling A. So in the next diagram, R1 and S handling different resources, and same here third diagram R, S, T are handling different requests. Third one here deadlock modeling third one. So in this example, how the deadlock is occurs and how it can be avoided. So here in the H diagram, so request R is holding A, but A is holding S, that S is holding again different resource, that is B, and T is holding C. So here no deadlocks. So here next diagram, the R is holding A, and A is holding S, and S is holding B, B is holding T, T is holding C. So there is a no deadlocks here. So these are the examples where deadlock modeling. So here one more example is given, how the deadlocks can be avoided. So here R and S is holding A, but C is holding R, T is holding C. So these are the example for the deadlocks. So what are the methods for handling deadlocks? So ignoring the problem, it may be go away. So use most operating system including Unix. Detection and recovery, let deadlocks occur, detection them and the take action. Third point, ensure that the system will never enter a deadlock state. Dynamic avoidance by carefully resource allocation. Prevention by structurally negating one of the 4 required conditions. So lastly, this deadlock detection allows system enter into the deadlock state, then detect the algorithm and recover that scheme. So these are the information regarding deadlocks. So finally, the session of the summary, what we are learned in today's class. So here the references are given related to this deadlock. The reference books are there, and below the website links are given below here. Thank you for viewing the session.